a great night to be doing some more transformations, ladies and gentlemen. Lesson 2.3 from your Dig Ideas, page 56, where we are going to continue with transformations. And tonight we are going to apply what we learned to draw a reflection in a coordinate plane and, of course, list the new image location. The essential question, how do you move a figure to look like its mirror image? And does this figure change after moving it? Now, ladies and gentlemen, this mirror image should give you a hint of what a reflection is already. Well, you've read some pages, so you should know. It's like looking in the mirror. So there is math that you see every single day that you look into the mirror because you see your reflection. A reflection is what? It's a flip. It's a mirror image. It is a mirror image of the original figure. And of course, every time you reflect or you see your mirror image, there is a line of reflection. Okay, when you look in the mirror, where would that line of reflection be? That's right. For some of you who said it is the front of the glass, that would be the line of reflection. Absolutely. And of course, one thing we got to remember is that every single transformation that is a reflection has this line of reflection. Something I want you to add to your notes right now. And what I want you to write is all corresponding parts are the same distance from the line of reflection. This is a very important concept that I'm not sure they talk about soon enough in the book. All corresponding parts are the same distance from the line of reflection. What does that mean? It means the point on the original figure is the same distance from the line of reflection as its image point, its corresponding point is. So here's how we look at that. So if I take this point, I'm going to make it black just because. If I make this point right here, and I measure that distance to the line of reflection, let's say that distance is 4 whatever, makes no difference. Well, the corresponding point on the image would be this point right here. And of course, that distance to the line of reflection would also be 4. That is the rule for a reflection. So this point down here would be the same distance from the line of reflection as its corresponding point right there. And we can say that those are 3. I don't care, but they are the same distance. Makes sense to me. So, ladies and gentlemen, what are we going to start with? We're going to start with identifying a reflection. And how are we going to identify? We're going to see, 1, is there a line of reflection? A line of reflection, some people think about it as also a line of symmetry. Because if you can take your image and your original figure and fold over the line of reflection, your two figures, the figure and the image, will land right on top of each other, all corresponding points perfectly matched up. But what we're going to do is we're going to take a look at this. So obviously we have the line of reflection right here, the black arrow, and we're going to see, is this point, the blue figure, is it a reflection of the red? So if we measure this point from here to here, is it the same distance as this original point to the line of reflection? And you know what? Just by looking at it, it seems to be. And as I look at the rest of the points, if I were to go from here to the line of reflection and its corresponding point, voila. If I started over here and measured that distance to the center, would that be the same as its corresponding point over there? And I think yes. Yes, this is a reflection. Alrighty, My answer to that one is yes, this is a reflection. Continuing on, telling again whether the blue figure is a reflection of the red figure. And this time our line of reflection is horizontal. It's going side to side. So what I would expect is if I flip that heart, it might have a different look to it. It wouldn't look exactly the same. It looks opposite. It's like looking in the mirror. If you put the letters up, if you put your name on a card and you put it up to the mirror, in the mirror it looks opposite. And when I look at these two hearts, the blue and the red, they look the same to me. Besides, if I measured from this point of the heart down to the line of reflection, is that the same distance as the corresponding point up? I say not, so no, this is not a reflection. It is not. All right? So, ladies and gentlemen, I gave you a handout for your quick writes. This is the first one. You have 3 to decide if the blue figure is a reflection of the red. Ladies and gentlemen, when you are done, take a quick break, a quick snack, come back. The second video is going to be just a tiny bit longer than normal. Thank you.